So hello everyone, I Raghvendra Singh welcomes you all in this channel. So today we are going to discuss complex variable. Complex variable. So you all know that what are the complex number, and you have solved many problems on the complex numbers in your 11th class, also in ITJ preparation. So today we will discuss about complex variable. Here variable means not constant value or changing value. It's always keep changing. Suppose we have x, we can put value of 1 2 3 in place of x, so that is called variable, not a fixed value kind of. Okay, so let me show you that what we will study. So this is graph paper. This is the syllabus which I am referring. This is the syllabus. Function of complex variable, limit, continuity and differentiability of the complex function, CR equations, analytic function, harmonic function, elementary. इन एलिमेंट्री इसमें एक्सपोनेंशियल भी आता है. और इज एक्सपोनेंशियल e to the power something, so graph is always increasing, that is exponential, trigonometric and logarithm, फिर conformal mapping. Okay, so firstly we will study analytic function. So before analytic we should also know about that what is complex number. Suppose we have z, we have function in z. So this is function, we can write it z as u plus iota v. So remember, this is real part, and this is imaginary part. This is imaginary part. This is real part and this is imaginary part. So most of the time हमें ये दिया हुआ होगा, तो हमें देखना होगा कौन सी रियल पार्ट है, कौन सी इमेजिनरी पार्ट है. सो वी विल कंसिडर u as a real part and v is a imaginary part. Okay, then we will be able to solve question. This will be also x comma y. We'll let this will be also x comma y. Okay, so now let me draw one line so that it can be more accurate. Now let's discuss about analytic function. Discuss about this analytic function. So what is analytic function? So by analytic functions we can say, if Cauchy-Riemann's theorem applies, then we can say it is Cartesian, it is analytic function. So Cauchy-Riemann theorem applied in Cartesian form. Cauchy-Riemann's theorem applied in Cartesian form. Then we can say it is analytic function. We say, now I will say Cauchy-Riemann, in short it is CR equation. Here we can use CR equation. Okay, so what does it mean? So fz is equal to, we can write u plus iota y. So if we partially differentiate, this is the symbol of partial differentiation. Del u by del x is equal to del u by del y. Okay, and minus del v by del x is equal to del v by del y. If in a particular given function these two conditions satisfies, then we can say it is a analytic function. Analytic function. Okay, it's very simple. We will be given a one function. We will differentiate with respect to x, with respect to y, and also v with respect to x with respect to y. Then we will see that del u by del x should be equal to del u by del y, and minus, here we will minus, remember, minus del v by del x should be equal to del v by del y. Then we can say it is analytic. Let's do the example. Example, we have we have to show that we have to show that the following so I have taken a second pen. We have to show that the following function is analytic. The following function is analytic. And find the derivative. Function is e to the power z. This is our function. Okay, so again remember here one thing, that e to the power z, and we know that z is equal to x plus iota y. So we will replace z by x plus iota y. So if suppose f of z is given, so e to the power x plus iota y. Okay, so now we know that e से हम सभी मल्टीप्लाई कर देंगे, then it will be something like this: e to the power x into e to the power iota y. Now remember here, e to the power iota y, we know that e to the power iota y can be written as cos y plus iota sin y. Cos y plus iota sin y. So e to the power x cos y plus iota sin y. Cos y plus iota sin y. Remember, this function is going on f of z. So now what we will do is, so we will multiply by e to the power x, e to the power x cos y plus iota e to the power x sin y, or we can write e to the power x cos y plus iota e to the power x sin y. So remember, this is real part and this is imaginary part. So this is u and this is v. Okay, so let's take it. U is e to the power x cos y, v is e to the power x sin y. So let me take it. So first of all, e to u is e to the power x cos y, e to the power x cos y, e to the power x cos y. So So we know that what we have to do, we have to prove it. We have to firstly partially differentiate with respect to x, then partially differentiate with respect to y, then v. So we will differentiate with respect to x first, del u by del x. Del u by del x. So first of all, we will e to the power x, this will be as it is, cos y as a constant, so cos y as it is. So there will be no change. So now del u by del y, e to the power x, as it is cos y. Cos y differentiation is minus sin y. So minus sin y. Okay, now let's come to v is equal to e to the power x sin y. Okay, so del v upon del x is equal to firstly x e to the power x sin y as it is, and del v upon del y equal to e to the power x cos y. Okay, now we have done this. Now we have to compare. Now we have to compare from CR equation. So what was CR equation? CR equation says that del u by del x should be equal to del u by del y. So del u by del x should be equal to del u del v by del x should be equal to what the equation says, that del u by del x should be equal to del v by del y, and minus del u by del x should be equal to del v by del x. Okay, so I think we need to correct here. I have done something mistake. Del u by del x should be equal to del v by del y, and minus del v by del x should be equal to del v by del u by del y. Okay, so we will compare right now. Del u by del x to this is equal to del v by del x, means this and this is equal. We can see it by cos y e to the power x sin y. No, not equal. Del u by del x is equal to del v by del y. So del v by del y, this is both same. So yeah, same. So here del u by del y is minus e to the power sin y. It is equal to del v by del x, del v by del x e to the power x sin y. Yeah, so it is equal, here will be minus, so it is equal, so we can write e to the power x sin y is equal to e to the power x cos y, e to the power x sin y. So yeah, both are equal. So according to CR equation. What do I mean by shear? Shear means Cauchy-Riemann equation. It satisfies shear equation. It satisfies. Hence, we can say it is analytic. It is analytic. Okay. Now let's move on to the second example. Let me drink water. So let's take example number 2. So fz x cube minus 3x y square plus 2xy plus iota 3x square y minus x square y square minus y cube is analytic and find f dash z. Is analytic find f dash z and find f dash z. So again we will compare it, then it is x and it is y. So this is u, so x cube minus 3xy square plus 2xy and v is equal to 3x square y minus x square plus y square minus y cube. That is v. So again we will do same thing, that del v by del x firstly. So del u by del x equal to 3x square minus 3y square plus 2y. Del u by del y minus 6xy plus 2x. Del v by del x 6xy minus 2x plus 0, doesn't need to write. So del v by del y is equal to 3x square minus 0 plus 2y minus 3y square. So now we will compare it. So this is first equation, this is second, this is third, and this is fourth. So firstly, del u by del x equal to del v by del y. So we can see here del u by del x, 3x square minus 3y square plus 2y, and del v by del y 3x square, del v by del y 3x square plus 2y minus 3y square. Yeah, so this is same. So we can see that we can write from first and fourth. Okay, and now minus del v by del x equal to del v by del y minus del v by del x minus del v by del x is this 6x y minus 2x and this minus 6x plus 2x. Doesn't matter, we will multiply by minus, v is minus, so this will be same. So hence we can also write from second and third. From second and third, same. From second and third. Okay, from second and third. So now we have to find f differentiation of f dash z. So what should we do? So f z is equal to, we know that x plus iota y. F dash z is equal to del u by del x plus iota del v by del x. So we know that del u by del x is equal to 3x square minus 3y square plus 2y plus iota del v by del x. Del v by del x minus 6xy minus 2x. So this is our final answer. F dash z is equal to. Okay, so what I did is basically I just have taken these which we have given, so I have differentiated with respect to x and with respect to y also. Then simply I have just satisfies the CR equations. Then after I put it in this, and this is our final answer. Okay, so let's discuss. Okay, now we will search in Google what is function of complex variable. So as we can see, a rule that associates a complex number w with each complex number z in a set S. This can be written as w is equal to f of z, which I have told you already. These are some domains, single valued, analytic. I have told you that what are analytic functions. It should satisfy Cauchy-Riemann theorems, and also u partial derivative of u is equal to partial derivative of v with respect to x. So I have told you everything. So this was all about this. Now if we will search continuity and differentiability of complex function. Continuity and differentiability of complex function. So as you can see, in complex analysis, a complex function is a continuous at the point of its limit at that point exists and equal the function value at the point. Okay, and we can also write like continuity where the points do not break. A complex function fz is continuous at point z theta if the following limit exists. Okay, limit z tends to z theta, fz is equal to, okay, got it. So as we can see, differentiability, we know polynomials, we know that all polynomials are differentiable and they are continuous. Polynomials in the complex variable z is both continuous and differentiable everywhere in the complex plane. Okay, we can also see relational function. Relational functions. What are relational functions? Fraction of polynomials are continuous and the differentiable everywhere except where the denominator is 0. Not always differentiable, as function like fz is equal to z to the power z square mod of z square is continuous everywhere but not differentiable at the point. Okay, so remember this, that if function is differentiable, then it is not important that it will be definitely a continuous. It can vary. Okay, so if we will go through a video, then these are some videos.
Hello friends, welcome to a equation में दिया गया है, that is f of I is equals to, अब यहाँ पर हमें x को 0 रखना है for
This all I have told you already.
limit z tend.
Okay, so now we will see CR equations. CR equations. CR equations. So full form is Cauchy-Riemann equations, a pair of partial differential equations that determine if a complex function is differentiable, and if so, its complex derivative. Okay, complex function is differentiable, but its derivative should be also differentiable. Okay, consist of the, it is Wikipedia about this. These I have told you, del u by del x is equal to del v by del y, and del u by del y in partial differentiation with respect to y should be equal to negative of del v upon del x. A relationship of derivative, holomorphic functions, analytic functions. I have told you analytic functions. If these equations will be satisfied, then we can say it is analytic. Okay, now let's move on to the harmonic functions. What are the harmonic functions? So I have told you that double differentiative with respect to x plus double differentiative with respect to y should be equal to 0. That is double differentiative. That is harmonic function. Or we can also Laplace equations. So we can read, harmonic functions in mathematics are twice continuously differentiable functions that satisfy Laplace equation. Okay, I have told you Laplace equation. Laplace equations, or we can say harmonic equation, both are same. This equation essentially states that the sum of the second partial derivative of the function with respect to the its linear is equal to 0 in sense of the harmonic function in one where the value at the point is average of its value around that point. Okay, so twice continuously differentiable satisfies Laplace equation. I have told you mean while property. So this all. Okay, so now we will see elementary. Okay, so what is conformal mapping? What is conformal mapping? Actually, I didn't discuss this topic in my notes. So conformal mapping is a transformation in mathematics, especially within the complex analysis, that preserves the angles between curves at each point. So these are complex plane transformation, angle preservation locally. Analytic functions, complex functions that are differentiable are conformable mapping, provided their derivatives is non-zero. Okay, so I have told you everything which I have discussed in my notebook. Okay, so we have next example. We have to determine the value of constants a comma b comma c comma d, and the function is giving x square plus 2axy plus by square plus iota x square plus 2dxy plus y square is analytic. Determine the value of constant ABCD f test set x square plus 2xy plus by square I x square plus 2dxy plus y square is analytic. Okay, so what we will do, as I have told you, that firstly we will satisfy the CR equations, that is Cauchy-Riemann equations. According this, like del u by del x, del u by del x, I have told you already that del u by del x should be equal to del v by del y, should be equal to del v by del y, and del v by minus del v by del x should be equal to del v by del u by del y, del u by del y, del u by del y. Okay, so now simply we know that this is our real part, means u, this is our imaginary part, means v. Okay, so u is equal to x square plus 2axy plus by square. So del u by del x is equal to 2x. Remember, we are here doing partial differentiation, so we will doing differentiation only with respect to x. So 2x plus 2ay plus 0, and del u by del y is equal to 0 plus 2ax plus 2by, and del v is equal to x square, this is v, x square plus 2dxy plus y square. Del v by del x is equal to 2x plus 2dy plus 0. Del v by del y is equal to x square 0, so 2dx plus 2y. Okay, yeah, so now we will equate it. We know that CR equation says that del u by del x should be equal to del v by del y, okay, so this is del u by del x, this is del v by del y. It means x is 2x plus 2ay is equal to del v by del y, 2dx plus 2y. Okay, we have to find the value of ABCD. Here is two constant, and we have two values. So how to solve it? This is, let me write on second page. Okay, second page. Let me draw a line for better representation. So we have this, right? 2x plus 2ay is equal to 2dx plus 2y. So basically we have to find, there are two variables and two equations. And another thing, if we compare it from del u by del y, so this is suppose equation number 1. From this equation, from this comparison CR equation, that del minus del v by del x minus del v by del x will be equal to minus del u by del l. So minus del v by del x, this is del v by del x, this is del v by del x. It means minus x square minus 2dxy minus y square is equal to del v by del y is equal to del u by del y, del u by del y means 2ax plus 2by. Okay, so from here what can we do? One thing, let me solve it here. Here's 2ax, here is x, so minus x square minus 2ax, this term going to the side. और क्या कर सकते हैं, और y terms should be second side, but here is 2dxy. Actually I have solved already values, so here value t is equal to 1, a is equal to 1, and c is equal to minus 1, and b is equal to minus 1. So these are values of constant. I'm not able to manipulate it. All this question is very simple. Firstly we have given this, we have let this is a real part and this is imaginary part. So this is real part, this is imaginary part. We have simply partially differentiated with x and y. Simply we get this, and after we have to just compare the equations, then we will get the solution. Okay, now let's move on to this second question. Now let's take third example. So we have to again, question says that show that the following function are analytic and find their derivative, or analytic and find their derivative, So f dash z, the function is given z e to the power z. Okay, so this is the function which we have given. Now we have to solve it. So for solving, we know that z, we can write x plus iota y. Okay, so f dash x plus iota y, here also we can write is equal to x plus iota y e to the power x plus iota y. Okay, so we will open it. So x plus iota y e to the power x into e to the power iota y, and we also know that e to the power iota y can be written as sin y plus iota cos y, so cos y plus iota sin y. So x plus iota y e to the power x can be written as cos y plus iota sin y. Now there are three terms. Now we will multiply simply. Firstly we are multiplying this, so cos x into cos y, and then x into sin y. Okay, so we are just doing this. So firstly to the power x will be as this, x into cos y, x into cos y plus x I sin y plus iota y cos y, iota y cos y, iota y cos y plus iota square sin y square, iota square sin y square, and here also iota y cos y square, or we can write sin y square. Same here, iota y sin y square. So now we know the iota square is equal to minus 1. So here will be minus 1. So e to the power x cos y plus x iota sin y plus iota y cos y minus y square minus y sin y. Okay, so now we will multiply by x also. Although we do not need to do this. So firstly we can see that here is only this, here is this, here is the term of I. So what we will do is e to the power x cos y minus y sin y plus iota x sin y plus y cos y. Okay, so as we can see that here it is real part and there is imaginary part. So real part is means u is e to the power x cos y minus e to the power x y sin y. And similarly v is equal to x sin y plus y cos y. Now simply what we have to do, again we will apply CR equation. What are CR equations? CR equations are del u by del x should be equal to del v by del y and del minus del v by del x should be equal to del v by del y. So these are equations. Okay, and now simply we'll compare it and we will be able to find if these equations satisfies, then it is analytic. And what about derivative? We will put, suppose we have fz is equal to, we have given this z e to the power z, so we can write here f x plus iota y is equal to x plus iota y and e to the power x plus iota y. So in x, del x by del u plus iota del v by del y by del x, del y by del y, and same here. So we will put the value and we will get the answer. So now let's discuss CR equations in polar form. CR equations in polar form. CR equations in polar form. So CR equations in polar form. We all know CR equations. And what does it mean by polar form? Polar form means now del u by del r is equal to 1 upon r del v by del theta. Del v by del theta. Okay, this is first one. And del u by del theta is equal to minus r del v by del r. So del v by del r. Okay, so this is polar form of complex number. Let me drink some water. Yeah, so I was discussing about polar forms. So this is del u v, as we know that we will give in u and v. Simply we have to differentiate with respect to r, partial differentiation, and then we have to differentiate with respect to theta. It's very simple, right? Okay, so let's discuss example. यहाँ पे कुछ ज़्यादा खास बताने के लिए है नहीं, बस दिस इज ऑल अबाउट पोलर फॉर्म्स. Find P if fz is equal to r square cos theta plus I r square sin p theta I r square sin p theta is analytic. Okay, we have to find P. This we have to find, and it is analytic. Remember, analytic means we have to differentiate with respect to R. So first of all, we all can get from here that what is U and what is V. U is equal to R square cos to theta, and V is equal to R square sin p theta. Okay, so now what should we do? Simply now differentiate with respect to r. So del u by del r. So here this will be 2r cos to theta as it is, cos to theta, and again cos theta is 0, so doesn't need to write that. This is del u by del r. Okay, and what about del v by del r? Del v by del r, this will be 2r sin p theta as it is. Okay, and what about del u by del theta? Del u by del theta is equal to r square as it is, cos 2 theta minus sin theta minus sin 2 theta. Now remember, chain rule we will apply. Here is 2 theta, so 2 theta differentiation of with respect to theta, it will be 2. Okay, so and now here del v upon del theta, so r square as it is, sin p theta is cos p theta. Okay, cos p theta. Remember, here is p theta. Now p theta will be differentiated with respect to theta, then here will be p again. Okay, yeah, so this is all. So now simply we will follow this equation. Let me compare it. So first this equation means del u by del r is equal to 1 upon r del v by del theta. Del v by del theta. What is the value of del u by del r? It is this. So 2r cos theta is equal to 1 upon r. 1 upon r. 1 upon r dv by d theta. dv by d theta is r square cos p theta into p. R square cos p theta into p. Okay. So from here this r to r cancel. 2r cos 2 theta. From here we can write 2r cos 2 theta is equal to r cos p theta into p. Okay. So from here what we can take common? We can take 2 common. R cos theta equal to r is equal to p common here we can take. So r cos theta. So r cos theta to r cos theta cancel. Okay, so p is equal to 2. You got the answer. We have to find p, which we have found it out. Now one more thing. Now if you will compare this one, then also you will get the same thing. The value of p will be 2. So I'm not doing that, because simply what we have to do, again we have to del u by del theta. We will del u by del theta. If we del u by del theta, we will take this one and then minus r, and then del v by del r. This is del v by del r. Simply we will put the value. Again we will get p is equal to 2. Okay. So now let's discuss about new concept. That will be harmonic function. Okay, so what do you think about harmonic function? So if you remember in our 12th class, we didn't study about harmonic function according to me, because I'm not able to recall. So in this concept basically nothing need to know so many things. हमें बस ये पता होना चाहिए कि double differentiation of u with respect to x plus double differentiation u with respect to y square should be equal to 0. Okay. So and we can also write double differentiation with respect to v to x plus double differentiation v with respect to y square is equal to 0. If this is equal to 0, then we can say function is harmonic. Function is harmonic. Got it? Yeah. Now, so let's take one example on it. Simply we know that what we have to given u and v, so we have differentiate with respect to x, double differentiation, and Why? If combination of both is equal to 0, then we will say that it is harmonic. It's very simple. Suppose we have example. So that the function u is equal to y cube minus 3x square y is a harmonic function. So see what we have given. U is given y cube minus 3x square y. So del u by del x first. So this will be 0 and minus 6x is y. Del again del square y upon del x square is equal to minus 6y. So first we have find it out, and now second, del u upon del y is equal to 3y square minus 3x square. 3y square minus 3x square. Okay, 3y square and minus 3x square. 3x square, and del square u upon del y square is equal to 6y minus 0. 6y minus 0. So from here, as we can see that del upon del x square plus del square u upon del y square is equal to 0. Minus 6y plus 6y is equal to 0. Okay. So hence we have proved it. Hence it is a harmonic. It is a harmonic function. Okay. Yeah. So now we have studied about analytic function, harmonic function, and now we will see another topic that will be construct an analytic function. That will be construct an analytic function. That will construct an analytic function. Okay. So here is total 4 types. Which type of types? When u is given and v is given, and so first is when when u is given. When u is given, so here are some steps to follow. Some steps to follow. First of all, find del u by del x. Del u by del y. Second, share equations. And third, f z in function of z is equal to x plus iota y, sorry, v plus iota v, and fourth is f dash z is equal to del u by del x plus iota del v by del x. And fifth is Milne-Thomson method. Milne-Thomson method. So what is Milne-Thomson method? Milne-Thomson method says if any function is given, put x is equal to z, and y is equal to 0. So this was the statement of Milne-Thomson theorem. And then the final step is integrate the function. Okay, so now let's discuss the example on it. We have to construct the analytic function, construct the analytic function whose real part is x to the power 4 minus 6x square y square plus y to the power 4. Okay, so remember here we have given that real part. Real part means this will be definitely u. This will be given in question. Okay, so we can write u is equal to x to the power 4 minus 6x square y square plus y to the power 4. So let's do in this. There is something which is already written. This is some work of mechanics. Don't see that. Okay, so we have given u is equal to this. So firstly we will find what del u by del x. So this will be 4x cube minus 12x y square del u by del y. So this will be 0, and here will be minus 12x square y. This will be 4y cube minus 12y square. So now CR equations. CR equations is the del u by del x is equal to del v by del y, and del minus del u by del y is equal to del v by del x. Well, this was CR equation. So basically here is only u function, and how can we compare it? Let me check it. So this was CR equation, and now third step is that f dash z is equal to u plus iota v, and f dash s f z, we can write it del x, so del u by del x plus iota del v by del x. We will put here that values del u by del x, del v by del u by del x. Yes, remember here I was saying that how can we compare it. So one thing which we have forgotten, जो कि हम भूल गए थे, that we have these values like del u by del x, del v by del y. Okay, we have found these values. Remember here whatever is del u by del x, del v by del y, del u by del x, del v by del y, this will be equal to 4x cube minus 12x y square. Okay, remember it, 4x cube minus 12x y square, 4x cube minus 12x y square, and minus del u by del y, del u by del y is equal to del v by del x. So we multiply by minus, this will be equal to 12x square y plus 4y cube. So पहले हमें पता नहीं थी कि वैल्यू क्या है del v by del y की. अभी हमने इसे कंपेयर करके हमने इसकी वैल्यू निकाल दी del v by del x और del v by del y की. Now simply we will put here, so del u by del x, del u by del x, del u by del x is 4x cube minus 12x y square plus iota del v by del x. This is del v by del x, 12x square minus 4y cube. So now sixth step says that by Milne-Thomson theorem, what he says that x is equal to, put x is equal to z and y is equal to 0. There was something which he said. So x is equal to z, we will put here, so 4z cube minus 12z minus 12z minus 12z into 0 because y is 0 plus iota 12 into z square minus 4 into 0. So what will be final function? 4z cube plus iota 12z square. Okay. Yeah, so now this 12x, oh sorry, remember this is here y, so we will put here y. Okay, so ये ध्यान रखना, थोड़ी बहुत मिस्टेक छोटी बहुत हो जाती है which cannot be remembered suddenly. I see on my solved examples, then after I realize it. So here will be again, this will be also 0, so this will be 0. This is only 4z cube. Now function f dash z is equal to 4z cube. So if differentiation will go that side, then that will be integration. So f z is equal to integration of 4z cube dot dz. So it will be 4z to the power 4 upon 4. 4 to 4 cancel, means z to the power 4 plus c. Okay, so this will be our final answer. There was something how we solve. So what I have done, this was the question, and just I have used the very simple methods, all steps. Now we will be given v, and then u plus v and u minus v, and then second type is when v is given, so we will find del v by del x and del v by del y, and all steps will remain same. What was all step? Firstly we will find it, then we will satisfy through CR equation so that we can find the other values, then we will differentiate, then we will then we will differentiate, then we will apply Milne-Thomson method, then we will integrate, and we will get the final answer. And the third and fourth type will be when u plus v is given or u minus v is given. So what we will do? We will do is simple that firstly we will find del u by del x and del u by del y, same with, then we share equations, then all the steps will remain same. I am not doing an example on it because it is too lengthy. Okay, so I hope I have discussed all concept of complex variable. This was all about this. Now one concept is also remaining, that is so one topic also we have discussed, that is one topic which we have to discuss is orthogonal curves, and orthogonal trajectories, and orthogonal trajectories, orthogonal trajectories. So there are some steps to do these type concepts, questions. What are that steps? That firstly we have to find del u by del y, and then CR equations, and then fz is equal to u plus iota v, and then Milne-Thomson method, and then we will integrate. And now the last step which makes it unique, that we will put z is equal to x plus iota y. So this is which we have to take care of in these questions, कि हमें लास्ट में z is equal to x plus iota y रखना है. यही इस क्वेश्चन को ज़्यादा कॉम्प्लिकेटेड बनाता है while solving these questions. So let's take one example. Find the orthogonal trajectories of the family of curve. Find the orthogonal trajectories of the family of curve e to the power minus x cos y plus xy is equal to alpha. So this is given. So let it is equal to u. Okay, so u is equal to e to the power x minus x cos y plus xy minus alpha. So it will be del u by del x minus u to the power minus x cos y plus y. Okay, so we are doing partial differentiation with respect to x, so e to the power minus x minus will be here, cos y and this. So del u by del y is equal to minus u to the power minus x sin y. So we are doing cos y differentiation will be minus sin y, so minus is here, plus plus xy is x. Okay, and now according to CR equations, now according to CR equations, del u by del x is equal to del v by del y, and del u by del y minus del v by del x. F z u plus iota v simply f dash z is equal to del u by del x plus iota del v by del y, del v by del y, del v by del y, no, del v by del x. So we have to put del u by del x, which we have found it here, del u by del x, and del v by del y, we have not get del v by del y, so this is equal to del v by del x. So minus will be plus. Okay, so I'm just putting the values. So e to the power minus z cos y plus y iota e to the power x minus x sin y minus x. And now applying Thomson method. Applying Milne-Thomson method. So what he said, that x is equal to z and y is equal to 0. So x is equal to z means here we will put z and y is equal to 0. So e to the power x minus e to the power x is equal to z, so we will put here z cos y, cos 0 plus iota e to the minus x, e to the power minus z plus sin 0, this will be 0 minus z. So here will be cos 0 1, so minus e to the power z and plus iota, here will be minus z. So now f dash z was e to the power minus z plus iota minus z. So we will integrate f z only, so e to the power minus z integration of it dot dz plus minus integration of z dot dz. Okay, so this will be f dash z, so e to the power minus z plus z square by 2 plus c, here will be minus z square by 2 plus c. So this is our final answer. What we did, simply we have just orthogonal trajectories, we have to simply find this, and then we have to put z plus, now last step is z is equal to x plus iota y. So we will put it in place of this, then we will get the final answer. So thank you for watching this video. Thank you for watching.